When we go upon finding a true subdivision and the split down to the left where we've gone, R becomes the split, so let's call that S. R becomes S, but first we push R onto our stack. Push R onto the stack, set R now to be the split, and we leave L. You could even call that an optimization. I'm not sure how much symmetry is allowed, because for the right slot it becomes useless on our way up, I think, but we're about to explore that situation algorithmically. So once we've gone down to the left, if we go down to the left again, we have to repeat that step. That's the crazy thing. So upon true, one just loops back onto itself, and upon false, it goes across, so we're about to explore across. Across to the right. So when we go across to the right, we need to we have this pushed onto the stack, so we need to pop that into R. We need to get R put into L, but we're going to want to save L for the way back up, so we're going to push L. Onto the stack. So what becomes of L? Well, L needs to be R, so that circles back in itself in the graphic for the algorithm. L we faithfully set to R. Now, exit conditions here. If this one, and in our model it has indeed failed, but if this one chooses to keep subdividing, then we must actually go back up here, so it joins back into that loop. If it's false, then we need to go back up the chain, and so upon false, we find ourselves here at stage 3, the up stage. Now, to go to this state from this state, and this would be true here as well. That's the thing. This should generalize further to every level. It's a recursive, recursion, recurrence, relation, all of those kinds of feedback loop, discrete mathematical ideas. Even, Turing machines, I'm sure that you could relate some kind of equivalence between all of them and prove. I'm going to be as bold as to say that you might be able to prove this to be viable for what I want to do, which is subdivide an object repeatedly into two, the binary space partition essentially, but it's kind of equal one that has conditional. I mean, all those things usually have some condition for when to stop, unless they're like a full, complete tree or whatever. It's not a complete tree. There's a point at which it must stop, and you have to visit the parent node first in order to evaluate that condition. Evaluate the function that will yield the result of that condition. To go up, we keep the right one, we've pushed L. So actually what we do is that we just pop L, we just pop into L, and then we're back here, and then we don't know whether to go across or go up because we don't know where we are. So perhaps there needs to be some kind of state where we decide based on whether it's an odd or even number where to go next. But up we know what must happen is that this stays and this just pops into there. So we're safe in the knowledge that L is set to the result of the pop of the stack we've created. Whew, so, gee whiz. Imagine if this was one of these ones. Let's go back up, and we've just gone up to here from there to Q11 from Q22. Well, then we need to know that the next stage is either across right or it's back up. So then we need to sort of say if we're a right leaf, then we're an even number, so n log 2 equals 0. We are a right leaf, and therefore if we come here we need to go back up, and so then that just loops back onto itself. Then we know that if n log 2 equals 1, then we need to go across right. So we've come back up to there and we need to find out that situation. And then at some stage up we'll check, what if n equals 0, then terminate to black dot or trying to remember discrete mathematics. symbol, Greek symbol is for terminate. Stop. And I can do that in red, because stop signs are red, even though that was just a rash decision. So it looks like from there we should be able to construct. We should be able to construct an algorithm.
You should be able to see for yourself what the next steps lie.
All the time, when the truth unfolds, everybody stops and they stare. And you think, who's the guy? Who's the guy that up here has the connections? Neural enrichment to realize that this is spaghetti on top of late undergraduate level mathematics. It's just it's not related to what has become the mainstream of coding, where we just fire up, Chrome and type in a few lines of JavaScript and shapes and colours are flying everywhere. And I've done that, it's fun. I don't see what more meditation could be achieved right here and right now. So I'm going to leave you with this board so that you can pause it and contemplate. I bid you adieu. You're welcome. Thank you for your concentration.